Tornqvist is the person with the most interesting name here today, but he's also a person who grew up in the Netherlands, and he has a degree from the Utrecht University. He's been in the United States of America for 10 years, but what I think is one of the most interesting facts about Torbjorn is that he arrived at Tulane University 3 days before Katrina. So in this audience here today, I know that's of some interest to you. I think that I'm sure his life and the pace of his life picked up dramatically after that. He said he was heading here from Chicago, sort of racing Katrina to Tulane. So Dr. Tornqvist is with the Department of Earth and Environmental Sciences at Tulane University, and he is an expert in climate change, coastal science, has a degree in physical geography, and of course there are differences in the degrees that are awarded in Europe versus here. His technical degree is in physical geography. He works a lot with geology here in the United States, and I think that he has a lot to tell us today about policy in again, weighing the processes at play in our very unique place that we live. I think one of the biggest understatements that Dr. Culp said in his presentation was, it's a little different here from other places. Well, yeah, that's why we all love living here, and that's also why we deal with problems that are very different from other places. Dr. Tornqvist, please begin your presentation.
I'll give you the punchline right away, and then I'll elaborate on that during the talk. But obviously, we have major challenges we're facing. On one hand, we have subsidence, which is, of course, an ongoing process that we are very concerned about. On the other hand, we have accelerated sea level rise. And one of the points I'm trying to make here is that I think in the longer term, sea level rise is going to be the most fundamental problem we'll have to deal with. Not surprisingly, perhaps, I put in a somewhat similar slide as Mark did, because this is arguably one of the most important papers that has come out in recent memory about the situation of the Mississippi Delta. So I'm going to focus essentially on the subjects that are captured in the upper diagram that shows predictions of sea level rise that incorporate different scenarios of subsidence and acceleration of sea level rise. That's really something my group has been working on quite a bit for the last decade, and I will basically focus on in this talk. If we can move to the next slide, I'm going to start off with what sea level has done over the time period for which we have pretty good measurements. So this is globally averaged. So these are measurements, the red symbols show measurements with tide gauges on the coast. At the very end of this record, if you look around the year 2000, you see a little black line. That's the period for which we have direct satellite observations. So what we see is a steady rise, and not only a steady rise, there is also a long-term acceleration in that rise. So this serves as one of the foundations for the predictions by the IPCC, and their more conventional scenarios predict that globally sea level will rise somewhere between 20 and 60 centimeters. Mark actually pointed out that there are other predictions that are more pessimistic. And the reason for that, and that's kind of illustrated by my next slide, is not here, but seemingly far away from here, places like Greenland and West Antarctica. Maybe you can click one more time, and you'll see that little circle that shows the location of this slide. What we see here in the background is a part of the Greenland ice sheet with one of its outlet glaciers that is actually one of the fastest moving glaciers in the world. That's been the case for as long as it's been on record. But in recent years, that glacier has about doubled in its speed. And it moves at an incredible rate. It fills this fjord with giant icebergs. Now, if it was only about this particular outlet glacier, we might not have to be too worried. The problem is that we see this in very large portions of the Greenland ice sheet, and we see similar phenomena in West Antarctica. And this is really one of the biggest things we have to worry about here in Louisiana in the longer term. Can you go on to the next slide? When it comes to the IPCC predictions, we are now at a really interesting point in time, because the IPCC has been around for more than 2 decades now. Their first assessment report came out in the year 1990, and that, of course, included a number of predictions for both temperature change and sea level rise as they could assess them back then. Now, since we're 20 years down the line, we can now actually compare the measured changes with the predictions that were made back then. And if you focus specifically on the lower graph here for sea level change, you can see the solid red line that then at the year 1990, it kind of diverges in different scenarios. You have the more optimistic scenarios, that lowest stippled line, and then you have the more pessimistic scenarios, the upper lines that go all the way upward. And behind that, you can actually see the measurements, the actual data, the facts. And what we see is that what has happened over the last 15 to 20 years is actually tracking the worst case predictions that were made in the year 1990. So if you can click the button, the question then, of course, is, are the IPCC predictions too conservative? And the prediction I just showed, the 20 to 60 centimeters, it has a major shortcoming, something that IPCC fully acknowledges, and that is that the role of the ice sheets is not fully captured. And the reason for that is that predicting the behavior of the ice sheets is extremely difficult, and the scientists involved just don't feel sufficiently comfortable to make any far-reaching predictions about them. But if we see what's happening with them right now, and if we look at what we see in this lower graph here, there is a lot of reason to be concerned. So let's move to what's happening here more locally. And the lower panel actually shows some graphs that also featured in Mark's talk. Two well-known tide gauges that show how sea level has changed over the last century, or much of the last century. Pensacola, Florida is widely believed to be one of the relatively most stable parts of the U.S. Gulf Coast. And you can see that the long-term trend is just over 2 millimeters per year. Maybe you can do another little click and I'll highlight those rates. As Mark pointed out, Grand Isle shows this very high rate of sea level rise, which I will show later is primarily due to high compaction rates of the relatively shallow deposits in the subsurface. Now, of course, to put these measurements in perspective, we want to know what the natural rates of sea level rise were prior to any major human activity. And we now have a very nice record that was collected a number of years ago by Juan Gonzalez, one of my now former students. This is a record for about 1,000-year interval, starting in the year 600, going all the way to the year 1600, so entirely prior to Industrial Revolution. And what we see is that the long-term trend is only about 0.5 millimeter per year. So we have steady ongoing sea level rise, but it's at a much lower rate than what we see now. So if we compare that to the Pensacola record, we see that on the Gulf Coast, by and large, sea level has accelerated about 4-fold, and possibly even more if we consider that right now the globally average sea level rise is about 3 millimeters per year. So we obviously have seen some very dramatic changes. That is at least one factor in all these coastal changes that we are observing. This is a very simple cartoon that kind of summarizes some of the key processes that Mark already discussed for the most part. So on one hand, of course, we have what we call eustatic sea level rise, which is really the sea level rise caused by things like melting of ice sheets. And then more locally, we have a variety of things that operate over different time scales, at different rates, and also in different parts of the subsurface. So we have compaction that is probably mostly important in the shallowest deposits. So that basically that large green triangle that is a very schematic view of the present day Mississippi Delta. Then of course we have faulting, as we discussed. We have things like fluid withdrawal. We have some kind of technical terms here which I will explain. Flexure is basically referring to the fact that the enormous weight of that sediment body is pushing down the crust of the earth. It's a very intriguing process we are also trying to understand in more detail, and I will actually show you some data that now tell us how important that process is. And then we have at the very bottom something else that you might not think of as being relevant here on the Gulf Coast. But glacial isostatic adjustment refers to the impact of glaciations in the past that covered much of North America. And we'll show that they actually have a significant impact even here on the Gulf Coast.